So I will now talk about how to use Keil for our fat exam purpose. The basic, I somehow suppose many of you will not even able to run the program. So for really basic stuff. So some project is open. I want to close this project first. So close project. Now this is fresh start. So new microvision project. So I'll give some name, say from some folder I have giving some name, say project 1. Okay, and I have to select legacy device P89 V5 1RD2. Yes, this guy I have to select OK. See, it is written 8051 base microcontroller. Okay, this I can select yes or no. I will click no. Okay, so now this thing is done. Now I'm gonna do what? I'm gonna write a new file. Okay, write a new file, and my first line would be org0h. Suppose I want to add two numbers, so move a comma hash 0304, move a comma hash 02, and add a comma r1. And so after I add this program, what would happen? I have to save it first. And to save it, I have to save it, so give it some name. So I can give some name, say dummy program dot asm. Okay, dummy program dot asm. Then save. Okay, as you save, you get this colorful, and then I have to load this program. So add existing files. To see dummy, where I did write dummy psm. Yes, then I add, and then I close. Okay, now how do I run it? This thing, okay, this I have to always make sure that you know what is the target frequency. So it's always better, unless the question other asks otherwise, always make sure you set the target frequency to 11.0592 megahertz. Okay, and for now we don't have to bother about anything much. Okay, and then you will do what? We will do first translate. Pardon the sound. Okay, I cannot reduce the sound. I'm not sure if my recording would get hampered then. Translate, and then build, and then rebuild, and once that is done, then you do debug. You click OK, and then before running, just see that in the left hand side all the registers, that R0 to R7, not all the registers, the register R0 to R7, there are more registers than this. The banks total 32 registers, physical different registers, and these are the system registers, like 21 system, 28 or 21 system registers you have. And this is the PSW, A, B, stack pointer max, DPTR, program counter, states I don't know, sake I don't know, PSW, and the bits of the PSW, and I'm going to run it. So deassembly will show the contents in the ROM. Deassembly showing the contents in the ROM. In 00 location, the opcode of move R1. Okay, and the following 002 location, 001 location, which is not shown here, the data 2 will be placed, and 002 location, the opcode of move A and data, and the data. So this is you can see that total 4 into 4 16 bits are placed over here. These two are will 02 will be placed in the 0003 location. Here also 4 will be placed in the 001 location, likewise. So I run it, and you see the registers will change accordingly. I can do step by step over. I can do over here. Let us go through step by step. First, if I run first, see the cursor is now over here, right? This yellow thing is pointing over here. This is the first line. The first line what is a directive, it is not a program. It is just saying the uh, my assembler that put the first instruction in the location 00h, or put the opcode of the first instruction in the location 00h of the ROM. So as I do first step by step, first this line is going to get executed, and this line, and so on. So let us go step 1. So now see R1 will change to 4. Step 2, A will be changed to 2. Alright, and then now 2 and 4 is going to get added, and A will result is going to get saved in A. So A6, probably it's very easy for most of you, but anyway. Or I could have done this button directly. Now you see no execute permission is it means that it is the program counter, whatever the address of the program counter, the in the corresponding address in the ROM, the data is not readable. They don't have the permission to read. It means they don't have anything over there, and no instruction. So now you can you could have done the whole thing in another way. You could have pressed reset and just run the program whole at once. Okay, so that's it.